Yes.
Yes.
Hello. Am I audible?
Yes, sir.
Okay.
Yes, sir, you're audible.
So we start some problems. We can take some problems. Yes. Okay. So we start with some problem related to the marks. Like for example, we have a one marks that is 4 cross 1. Okay. For the selection, we have a 4 inputs. Okay, and we have a 2 select line. I just mentioned this is the I naught, I1, I2, I3. This is the S1 and S naught. I connect A, B, C101. What is my final output? You want this type of questions? Students, yes, please.
Yes, sir. This type of questions, and also some questions like how many uh this mux can we use to make such as AND gates or gates kind of.
Okay. Okay, so I just go through with that one. If you require some more questions, so just tell me. Okay, so like for example, we have this question. I just solve one question. So I know that my expression y is what? Simply first of all, I write down the equation I naught s1 bar s naught bar. When I naught will be selected when both are 0 0. Okay, when it is 0 1, so that means s1 is 0 and s naught is 1. Select the I1. When S1 is 1 and S naught is 0, select the I2. And when both are 1 1, select I3. Okay. Now I directly put the values. So if you can see that at I naught I connect the 1. So it is a bar B bar plus I1 we connect the C A bar B plus again I2 is 1 A B bar plus I3 if you can see that it is 0, so I just connect directly 0. So y, so if I write in the form of a b c, so I'm getting the a bar b bar plus a bar b c plus a b bar. Okay, for a standard SOP form, if I convert, so it is a bar b bar, I multiply with c plus c bar plus a bar b c plus a b bar, I multiply again c plus c bar. So it is a bar b bar c plus a bar b bar c bar plus a bar b c plus a b bar c plus a b bar c bar. Okay, so one of possibilities is that. Second is that I ask the sigma m. So sigma m it is a 0. This one will be 1. This one is 3. This one is 5. And this one is 4. Okay. So it will be 0, 1, 3, 4, and 5. Okay. For example, I have to implement y is equal to a b bar c plus a b c bar plus a bar b bar. Okay. I have to implement this one using mux. So I know that this is a three variable input. So if anything is not mentioned in the question, I can use a 4 cross 1 mux. Okay. I connected A and B here. This is the S1, this is the S0. Here I connected, yes, wait a minute. I0, I1, I2 and I3. Okay. Now thing is that if I connected A and B and a select line, so these two inputs are my select line. 2 is my select line. These two are my select line. Okay. So A bar, B bar, that means my select line S1 and S0 both are 0, 0. Okay. A bar, B bar, that means my select line S1 and S0 both are 0, 0. So which input is selected as the output?
I0.
I0. Now if
I,
you see that with this term, 1 is multiplied. So that means I0 is connected with 1. Okay. Now second is A B bar. That means S1 is 1, S0 is 0. S1 is 1, S0 is 0. Which input is selected?
I2.
I2. So I2, if you see that this term is multiplied with C, so C I multiply here. Okay. And third term is AB. Okay. So when AB, that means S1 is 1, S0 is 1. I3 selected. So I3. Again, it is multiplied with C, so C I multiply here. Okay. Only one combination I1 is remaining. So I just multiply I1 with 0. Because no term related to the I1 will be there. So I just multiply it with 0. So automatically this term will be 0. Understood?
yes, sir.
The second way to
Yes,
solve
sir.
this type of question is we have this type of question. So what I do is I just do A B bar C plus A B C plus A bar B bar. Okay. So first of all, I convert into the canonical form. So I multiply C and C bar. So I am getting A B bar C plus A B C plus A bar B bar C plus A bar B bar C bar. Okay. So this is M0. This one is M1, M7 and M5. So four terms are available. Understood? Now I create a table. This table is little bit different with K-map. Okay, this is not a K-map table. This table is little bit different with K-map. Okay, so here 0, 0, 0, 1, 1, 0 and 1, 1. Okay, in the K-map, what we do, we are representing in the gray code form, but here I am just representing 0, 0, 0, 1, 1, 0, 1, 1. So that means this one represent the I0. This one represent the I1. That means if I have a select line these, so my I0 is selected. If my select line position is 0, 1, I1 is selected. If my select line position is 1, 0, I2 is selected. And if my select line position is 1, 1, I3 will be selected. Okay, this is the A, B, A, B, A, B, A, B. Now here I connected a C as a C bar and C.
Excuse me, sir.
Yes, Sudhanshu.
Sir, I have a doubt, sir. Here, I have a sigma mean term 01345.
Yeah, tell me.
So, sir, actually, there I have a confusion. Even it
Hmm.
was not clear from the video lecture. So, will
Okay,
you please repeat and tell me how to write this?
okay. How I can write it? Okay, so I just okay. That conversion is okay, fine. How we convert the standard canonical form? Any doubt in this
Yeah,
one?
yeah. No,
Okay,
no doubt.
okay. Now, if I am talking about the mean terms, so in the case of mean term, the bar will be represented either A bar, B bar, or C bar. If it is represent, I can represent as a 0. And if A, B, C is there, I can represent as a 1. Okay. Similarly, if I am talking about the max term, this is opposite. A bar, B bar, C bar as a 1, and A, B, and C as a 0. Okay. So we have a mean terms form. So I just write as a 0, 0, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, and 1, 0, 0. Now this is the binary representation of 4, 5, 3, 0, and 1. So either I can represent it as a sigma m 0, 1, 3, 4, or 5, or I can represent it as a m0 plus m1 plus m3 plus m4 plus m5. Why? Clear, Sudhanshu?
Yes, sir. Now it is clear. Thanks, sir.
Okay. Okay, now we go with this particularly thing. Okay, so we represent a table. Okay, in this representation, I just write a 0, 0, 0, 1, 1, 0, and 1, 1. Why I am representing in this one? In the gray code, sorry, K map, we represent in the gray scale. But here, I just put the value according to selection line. If it is 0, 0, I naught will be selected, 0, 1, I1 is selected, 1, 0, I2 is selected, and 1, 1, I3 is selected. Any doubt till now? Okay. We have a Y, A, B, C. That means A, B, and C. A is 0, B is 1, and C is 0. A is 1, B is 0, and C is 0. A is 1, B is 1, and C is 0. If for this one, A is 0, B is 0, C is 1. A is 0, B is 1, and C is 0. A is 1, B is 0, and C is 1. And A 1, 1, 1. So I write a binary representation of every block. Clear? Any doubt? Any doubt?
No, sir.
Okay.
Sir,
Yeah.
should I1 be 0, 1, 1 or
Which one?
in the C1, not the C bar, C1 in the inside the box? Shouldn't
Yeah.
I1 be 0, 1, 1?
0, 1, 0. A is 0. B is 1. Oh, sorry. 0, 1, 1. Sorry.
Yes, sir.
0, 1, 1. Fine. Okay. So the number is clear, I think so. Now I mark where the mean term is present. Mean term is present as 0. Mean term is present as 1. Mean term is present as 5. And mean term is present at 7. Okay. Any doubt? Now in this, only make a group of column wise. If complete column is cover, that means value is 1. Why? Because that means if those two terms are present, these two terms, so for the first term C bar is there, and for the second term C is there, and C bar and C is 1. So that way I represent a 1 here. For the I1, no term is present, so I mention it 0. Okay. For the I2, only this term is present, that means C. And for the I3, this term is present, that means again C. So connected here 1 I0, 0 I1, I2 is C, and I3 is C. Any doubt? I should repeat the same particularly question. I just change the select line. For example, now my select line is A and C. This is I0, I1, I2, I3, and Y. I just change my select line. Again, table is created. 4 columns are there. For the first row, one is the B bar, and second row B. It is 0, 0, 0, 1, 1, 1, 1, sorry, 1, 0, and 1, 1. Remember that this is different from K-map. This is not a K-map. Okay, this is the values of select line. So if 0, 0 is the select line, I0 is selected. 0, 1 is the select line, I1 is selected. 1, 0 is the select line, I2 is selected, and 1, 1 is the line, I3 is selected. And this is the value of AC, AC, A and C, A and C. Now for this column, what is the value? 0, 0, 0. A is 0, B is 0, and C is 0. For this one, 0, 0, 1. A is 0, B is 0, and C is 1. Here A is 1, B is 0, and C is 0. And here A is 1, B is 0, and C is 1. For this one, 0, 1, 0, 0, 1, 1. Why? Because B is 1. 1, 1, 0, and 1, 1, 1. Okay, understood? Now, where the terms will be defined? Terms is defined at M0, M1, M5, and M7. So M0, M1, where is the M1? Here M1. M5, the line is here, and M7 line is here. Okay. Column group is this one. That means I3 is that means I3 is 1
1,
because both column covered. I2 is
0,
2, and I1 is
B bar,
B bar, and I0 is again
B
B bar.
bar.
Okay. So if you connect a 4 cross 1, where it is B bar, 0, and 1. Here I connect A and C and Y. I0, I1, I2, I3, that is S1 and S2. Now you can draw the equation and you just check the equation should be same. Okay, now I write the equation for this one to verify. So Y is I naught S1 bar S naught bar plus I1 S1 bar S naught plus I2 S1 S naught bar plus I3 S1 S naught. Okay, now I naught is B bar A bar C bar plus I1 is B bar A bar C plus I2 0, so this term is 0 plus AC because I3 is 1. So this term is A bar B bar C bar plus A bar B bar C plus, now for this one I can convert into the standard canonical form, so I multiply with B plus B bar. So A B C plus A B bar C. This one is M0 M0 plus this one is M1 M1 plus this one is M5 M5 plus this one is M7 M7. Okay. Shubhendu? Sorry.
Oh,
Yeah,
so the
Sudhanshu,
yeah,
it is
so
clear how we write that one?
yeah, but sir, one confusion. Sir,
Huh?
in the first line, how
Hmm.
it will be how it will be zero.
Hmm.
I2 S1 S0 bar.
This one,
No, this is the first line. Y is equal to.
I note.
No, so
Okay,
you
this one is 0.
yeah,
Why
but
this one? How this one is 0?
yeah, yes, sir.
Because I2 is 0, na? If you multiply any value you have taken, select line S1 and S1, no, but I2 is 0, so this complete term should be 0. What we connected in the output?
Uh,
0.
oh yes, got it, sir. Thanks.
Okay. Here I1 is 0 when we select A and B as a select line and C as the input. Okay, but when I change my select line A and C and input is B, so I2 is 0. So this term is 0 here. Clear?
Yes, sir. Clear.
Okay. So now if I take one more question. Four cross one marks. I just take a little bit complex. So here I go with B. Here I go with A. Okay, I use this A with B using OR gate. So this is I3. B with 1. I connected as a XOR gate. That is I2. This one will be go as a I1. Okay, and here I connected as a I0 as a and C and gate and connected here. Okay. So what is my y? The equation for y is always same. That is I naught S1 bar S0 bar. This is my S1. This is my S0. I1 S1 bar S0 plus I2 S1 S naught bar plus I3 S1 S naught. Okay, now put the value of S1 and S naught. So Y is I naught A bar C bar plus I1 A bar C plus I2 AC bar plus I3 AC. Now I calculate the value of I1, I2, I3 and I0, I1, I2 and I3. So I0 is what? Ending of A and C. So A, C. Okay. I1 is 1. I2 is XORing of 1 and XOR with B. Okay. And if you remember, when we discuss the XOR gate, we discussed that if one input is 1 fixed as a 1, so the output, the basically XOR gate will be behave as a inverter.
So it will be bar.
So it is a B bar. Any doubt in this one you can ask.
No, sir.
Okay.
No, sir.
And I3 is B plus A. So I can write as a plus B. Clear? Now these four values I put in the equation. So Y is A, C, A bar, C bar. I1 is 1 dot A bar C. I2 is B bar A C bar. And I3 is A plus B AC. Now this term is
0.
0. Why? Because A dot A bar
A
or
dot A is 0 and C dot C bar is 0.
also 0. Okay, so A dot A bar, if I consider the A dot A bar, so this term is 0. Plus, I convert into the standard canonical form, so A bar multiply with B plus B bar C. It is A B bar C bar. And here, if I multiply with A, so it is A dot AC plus, if I multiply with B, so it is A B C. Okay. Again, I convert this form into the standard canonical form because A dot A is simply A. So A B plus B bar C plus A B C plus A B bar C bar plus A bar B C plus A bar B bar C. So finally Y is A bar B C plus A bar B bar C plus A B bar C bar plus A B C plus A B bar C plus A B C. Okay. Now this one is M3, M1, M4, M7, M5, and this one is also M7. So I just neglect this one. Or I can write as a sigma M 1, 3, 4, 5, and 7. Okay. Now I solve in the way this circuit is given. Okay. Now I solve into the simplified form. Okay. I design a basically, or I calculate what should I connect an I0, I1, I2 and I3 to get this. Okay, why should I connect an I0, I1, I2, I3 to get this SOP form? So again, create this table. 0 0 0 1 1 1 1 0. This is AC. I am considering AC, 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 and AC. This is B bar and B. Okay. The value is 0 0 0 0 0 1 1 0 1 and 1 0 0. Sorry, this is 0 and 1. Sorry. So it is a 1 0 0 and 1 0 1. Okay, it is 0 1 0 0 1 1 1 1 0 and 1 1 1. Okay, so this is the block binary. Now I put the values. So M1 is there, M1 is this one, M3 is there, M3 is this one, M4 this one, M5 this one, and M7. Okay, so this is I0, because when the select line is 0 0, I0 is select, 0 1 I1 is select, 1 0 I2 is select, and 1 1 I3 is select. So if you see that I3 both 1, so I3 connected with 1, I2 B bar, I1 both 1, that means 1, and I0 no 1, that means 0. So my simplified circuit is, I designed 4 cross 1. Here I connect 0, here I connect 1, here I connect B bar, here I connect 1. This is my A, this is my C, the output is Y. This circuit and this circuit both will be generating the same output. Okay, both will be generating the same output. Then only the difference is, here we required 1 2 3 different gate, here no gate is required. Or if B is not available, so I just required a one NOT gate with B, and this is 1 to get a output B bar. Okay, so if this circuit is available, I have to simplify that one. How many is required? 4 cross 1, mux required 1, and NOT gate required 1. I am getting the same expression. Clear? Any doubt? Anyone have any doubt?
Sir, if
Yeah.
we take a four variable like A, B, and C and D, then
Yeah.
we take A, B by making a table. Then we take combination of A, B, and C, D together.
Yes. Okay. I will go with that part also. Okay. Now we are solving that one with the help of 4 cross 1. Now if 2 cross 1 is available, 4 cross 1 is not available. The same expression I have to implement with 2 cross 1. That means one select line is available. I use as a select line. This is I0, this is I1. Okay. First we simplified this one. Now if the 4 variable, we can easily solve with the 8 cross 1 mux easily, but with the 4 cross 1 we are using the same method. Okay, so my select line is 2, so that means now my column is 2, but number of rows is 4. Okay, the value of column is either 0 or 1. If 0 is selected, that means I0 is selected, and if it is 1, I1 is selected. Okay, and here I take a input, like for example I connected select line as A, so this is my A bar and A. Now I am taking BC here, so it is 0 0 0 1 1 0 and 1 1. Again, remember that we are not taking in the KMF form. We are taking directly binary form. Okay. What is the value of this column? 0 0 0, because A is 0, BC is 0 0. 0 0 1, 0 1 0, 0 1 1. And here 1 0 0, 1 0 1, 1 1 0, and 1 1 1. Any doubt in this one? Numbering. Okay, A is the MSB. So if for this one A is 0, for this one A is 1. MSB is 1. Okay, now the terms are available is 1, 3, 4, 5, and 7. So 1 is here. I write is 1 is here. Okay, for Bohr matrix. 1, 3. Okay, now 4, 5, and 7. Clear? Now, if I make a group of these two, okay, make a group of these two. So you can see the C is constant, B is variable. Okay, so for this one, I write as simply C. Okay, I can directly write as C because C is constant. But for the second column, if you see this, and this one, not a individual variable is a constant. Not a individual variable is constant because B is constant for these two, but C is constant for these two. Okay, and in between these two, no constant. Okay, so I write a terms here. So this is the B bar C bar plus B bar C plus BC. Okay, take a common from here C. So it is a C plus B bar C bar. Why? Because when I take a common C, so B plus B bar is remaining, and that is 1. Okay, now from this one, I apply A plus BC formula, distributed law. So it is C plus B bar. Okay, so that means here what should I connect? I connect a C plus B bar. So my I0 is directly connected with C, but I1 is connected in the combination of variable. So I use a B, apply a NOT gate. Okay, along with that, I just use a C, apply OR gate, and the output of OR gate I connected at I1. So my Y is again sigma M 1 3 4 5 7. Okay, any doubt?
No, sir.
Okay, because you know that with the single variable I can't achieve, either I connect I1 with the single variable, I can't achieve all the expressions. So what should I do? I have to use the combination of two variables, because one will be used as a select line, but two variables are remaining. So I have to use two variables, and the combination of two variables I have to use on I1. So that's why I simplify I1 for the I1, simplify the expression for I1, and now use that particularly expression, or basically implement that expression and connect it with the I1. So my expression should be same. If you want to verify, I will verify that one. Okay, so my expression for Y is I naught S bar plus I1S. Okay, what is I naught? I naught is C dot S bar is A bar plus what is I1? I already solved that. So C plus B bar A. Okay, so this is the A bar C plus AC plus AB bar. Okay, so now I use the canonical form, convert into the canonical form. So it is A bar B plus B bar C plus A B plus B bar times C plus A B bar C plus C bar. So it is A bar B C plus A bar B bar C plus A B C plus A B bar C plus A B bar C plus A B bar C bar. So it is 3 M3 is available. This is 1 M1 is available. This one is 7 M7 is available. This one is 5 M5 is available. This is again 5 already we cover, and this is 4 M4 is available. So that is sigma M 1 3 4 5 and 7. Okay, so we verify also. Clear? Any doubt? Okay. So now if we have a, like for example, we have a sigma M 1 3 5 7 8 11 12 14 and 15. Okay, I can easily solve with the 8 cross 1 marks. Okay, so we have a B C 3 select line for 8 cross 1 marks, 1 output line Y. This is I0, I1, I2, I3, I4, I5, I6 and I7. Okay, so what should we do? We have to create a table. Now 3 select line, that means 8 combinations possible, so I create a 8 columns. And 1 row. Okay, so we are using 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. When this is the select line, so I naught is selected. When this is the select line, I1, I2, I3, I4, I5, I6 and I7. Okay, this is only remaining is the D, so I am taking D bar as a here and D bar D as a here. The value is 0 0 0 0 0 0 1 0 because D is 0. 0 1 0 ABC as it is, D 0. ABC as it is, D 0. It is 0 0 0 1 0 0 1 1. Okay. Now, which mean terms are defined? So 1 is defined, 3 is defined, 5 is defined, 7 is defined, 8 is defined, 11 is defined, 12 is defined, 14 and 15 is defined. Okay, so I0 is what? D. I1 is D. I2 is D. I3 is D. So I just connect D and short it all. Okay. I4 is D bar. So if D bar is required, so I use one NOT gate and connected it with D. If complement is available, that is no issue. If complement input is not available, then I use one complement gate, D bar. I5 is again D. So I use the same point and use the I5. I6 is again D bar. So I use this point and shorted it I6. And I7 is 1. Simple. 8 cross 1, no issue. If we go with the 4 cross 1, so I am just using the A and B as a select line. Sorry, S1, S0, that is A and B. This is the I0, I1, I2, and I3. Now input combination, two particularly variables are available. So two input combinations, so that's why 4 rows and two, because of two select line, 4 select line combinations of 4 columns. Okay, when both select line is 0 0, I0 0 1, I1 1 0, I2 and 1 1, I3. Okay, here 0 0, 0 1, 1 0, and 1 1. So the value is A B C D 0 0 0 0, 0 1 0 0, 1 0 0 0, 1 1 0 0. This 0 0 0 1. Okay, so simply 0 1 2 3. Then next row is 4 4 5 6 7. The next column, sorry, next column is 8 9 10 11 and 12 13 14 15. So you can, I think you can write now 1 3 5 7. So 1 is here, 3 is here, 5 7, 8 11, 12 14 and 15. Okay, now make a group. If I create this group, so you can see C is the variable, D is the constant. So the value of D is 1, so here I connected D. For this group, same. C is the variable because C here it is 0, here it is 1. But D is 1. So D. From this one, you can see both will be variable. Okay. So I can write as C X naught D. Because what is the equation for I2? C bar D bar plus CD. So that is C X naught D. So I write as C X naught D. Any doubt? Okay. Now for the third last column, 3 terms are available. 1 2 3. Again I say that for the, if 3 rows are available and 3 make a group of 3 rows, so not a single variable is a constant, so I have to solve it. So I just solve it here. I3 is equal to C bar D bar plus C D bar plus CD. Now from this one I take a C as a common, so D plus D bar is 1 plus C bar D bar. Okay. Now apply the distributive law A plus BC, that is equal to A plus B into A plus C. So C plus C bar into C plus D bar. It is again 1. So that means only C plus D bar is remaining. So here I connect a C plus D bar. Okay. So for the I0 and I1, both is DD. So I short, make it short and connected it with D. For the I2, it is a C X0. So I use a X0 gate. Where one input is C, second input is D. And for the I3, I just use a C. Okay, take a D as a with the inverter. It is D bar. Both will be OR gate. So I use one OR gate and connected with I3. That is why. Okay. Now any doubt in this point, you can tell me. Any doubt?
No, sir.
Okay.
Sir, practice
Yeah.
assignment question number 3. I have a doubt.
Week.
Week 6.
Okay. Week 6. Question number 3. Okay, the question number 3 is for the practice assignment. We have a 1 2 cross 1 marks. And the select line is B. It is C and it is C bar. So Y is here. Y I just mentioned it is a Y1. Now this Y1 will be go as a select line. It is again a 2 cross 1. It is 0 and it is A F. Okay, so first of all I write a Y1. So what is Y1? I0 S bar plus I1S. Now I0 is C S bar. S bar matlab B bar plus I1. I1 is C bar and that is B. Clear? So this is my Y1. Okay, now I just say that this is my select line for F. So F is I0 S bar plus I1S. Now for the F, you can see I0 is 0. So this term is completely 0. Why? Because I0 is 0. Okay, only the term is I1S. I1 is A time S. Now what is S? S is this one. A, B, C bar plus A, B bar C. Okay,
Yes, sir. Got it. Thank you.
so option D is correct. Any other doubt?
Sir, I have a doubt
Hmm.
related to decoder.
Okay,
Yes,
tell
sir.
me the decoder part.
Practice 7, question number 5.
Question number 5. Okay, question number 5. Okay, I just tell you a little bit about the decoder first. So, like for example, we have a 3x8 decoder. Okay, so in this one, the decoder's configuration is that if we have a n input, we have a 2 raised to power n output lines. Okay, so if we are talking about the 3x8 decoder, that means we have a 3 input line, that is the I0, I1, and I2, and we have a 8 output line. Sometime it is written as O0, O1, O2, O3, O4, O5, O6, O7, or maybe Y0, Y1, Y2, or maybe D0, D1, D2. That is the representation only. But we have a 8 output line if we have a 3 input line. Now if I draw the table, so what is the table says that I2, I1, I0, and with respect to this one we have a D7, D6, D5, D4, D3. So a little bit here. D2, D1, and D0. If my input are 0, 0, 0, okay, that means the binary representation of 0, 0, 0 is 0, so that means D0 is 1. 0, 0, 1, D1 is 1, except everything is 0. 0, 1, 0, so binary representation is 2, so 2 is 1, except this one, everything is 0. For 3, D3 is 1, everything is 0. 4, D4 is 1, everything is 0. 5, D5 is 1, 6, D6 is 1, 7, D7 is 1. Okay, this is the decoder part. Okay, now if we go with the question, so in the question they are mentioning let's take a little bit here. So they mentioned D0, D1, D2, D3, D4, D5, D6, and D7. They use one OR gate. complement of that one. Connected I0, D0, D3, D6. Only okay, 3 terms are available. Suppose, for example, I am not connected a NOT gate here. I am connected a simply OR gate. Okay. So what is my F? What is my F?
0,
D0 plus
D3, D7,
D.
D6.
Okay. So that is sigma M036. Clear? If
Yes.
I apply a bar here, so what happen? Okay, I just tell a little bit in more better way. Like for example, if I have a F that is equal to sigma M036, can I write it as a pi capital M 1, 2, 4, 5, and 7? Any doubt in this one?
No, sir.
Okay.
No, sir.
If I connect a NOT gate here, okay. If I connect a NOT gate here, so what happen in this particularly 3 position where the output is 1, after connecting a NOT gate, the output is 0 here. Simply, any doubt in this one?
No, sir.
Or here pi m, that means it is a POS term, that means the output is 0 here. That means if I connect a NOT gate here, so then means this output will be 1. So simply I can write, if I have a F and I apply a NOT gate, so after applying a NOT gate, this sigma m becomes pi m. Why? Because where the output is 1, now after applying the NOT gate, it becomes a 0, and 0, for 0 we represent a POS term. So sigma m, sorry, pi m 036 or sigma m 1, 2, 4, 5, and 7. Is it clear?
Yes, sir.
Now in the question, this is simply F. We already calculate that F is this one. Now I apply a NOT gate. Simply F is this one. I apply a NOT gate. So F bar. If I say this is the F bar, so I apply F bar here. Now after passing a NOT gate, I am having a F. So both will be the correct answer. Understood? Any doubt?
No, sir. Thank you.
Like for an example, I am taking one more case. If this is a 3 cross 8, like this is my question. Okay, I have a I0, I1, I2. I apply a 3 cross 8 decoder. This is the D0, D3, D5, and D7. Here I connected with the NOT gate. Okay, so if I say in the previous question, what I should I take, my f will be, so I again repeat it, I convert into the simply AND gate, oh sorry, OR gate, and again I apply at a dot gate. Here I consider it is a f bar, now it is a f. So first of all, I write the equation of f bar. So f bar is nothing but this d naught, d3, d5 and d7. Okay, but with NOT gate. So this is the d naught bar plus d3 bar plus d5 bar plus d7 bar. Okay. Any doubt? Yes, any doubt?
No, sir.
Okay. Now I have to take a f. So what is f? Take a complement. So d naught bar plus d3 bar plus d5 bar plus d7 bar. Okay, and if I take a apply the De Morgan's theorem, so it is a d naught double bar. This or will be converted in the AND d3 double bar, d5 double bar, and d7 double bar. So that is a d naught dot d3 dot d5 dot d7. This f is d naught dot d3 dot d5 dot d7. This is your f. Now in what way they are asking, according to this one you can convert it. They are asking you the Boolean expression form, like they are asking that it is the a b c. So what is d naught? D naught we are getting when a b bar c bar is available. D3 you are getting, so you have to solve it little bit more. A bar b c, d5 is a b bar c, and d7 is a b c. So this is your d7, this is your d5, this is your d3, and this is your d naught. Okay, so in what way they are asking, according to this one you can convert. Okay.
Yes, sir.
So I think we'll stop here. In the next class, we will discuss some more problems related to decoder, demultiplexers. So every doubt, I think it will be clear to you. Okay. Till that, you just practice a little bit more. If any doubt you are facing, so we will solve that, or otherwise we will take some other more questions. Thank you. Thank you all.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Yes.